Hello, everybody. So this is the second video dealing with solving radical equations. And this is, you're looking at the workbook. So we have several problems. We will solve many of these problems and leave you a couple there to solve yourself, okay? So let's take a look at the problems I selected for us to solve. So remember, I'll write it here on the corner. The 4 steps, right? We have to isolate the radical. 2, we have to raise both sides of the equation to the index. 3, we have to solve the remaining equation, which is going to be either a linear or quadratic. And 4, we have to check. We have to check that the solution works, all right? We may have one solution, we may have both. Both may work, one may work, the other may not, or both may not work. So we have to do that. Okay, so let's begin with 21.4. In this case, notice that the radical is already isolated. The index is 2. So I'm going to raise both sides of the equation, not just the left, both sides of the equation by the index, which is by default 2. On the left side, the radical will cancel with the exponent being raised. I am left with the radicand, the stuff that's inside the radical. And then 8 squared, 64. Right? Okay, so we raise both sides of the equation. This is what I have to solve now, step 3. Add 8 to both sides. Right, cancel. I'm left with 9x here and 72. Now divide both sides by 9. Right, the 9's cancel, and I have 8. At this point, I have to go back into the original equation, and I have to see if it works. So I have to check. Now, again, here in the workbook, we're reminding you check. But on the exam, we're not going to tell you that. You have to remember that radical equations have to be checked. So replace 9 with the answer you got and see if that works. All right, so 9 times 8, 72, minus 8, 64. Square root of 64 is 8, so that checks. All right, so we're good. Nothing needs to be done. 8 is the correct answer. All right, next case, 21.5. In this case, notice, and again, here are the steps. Notice that the radical is not isolated, and this number cannot be here. So I have to remove it by subtracting 2 from both sides. When I do, I end up with 3x minus 6 equals 5 minus 2, which is 3. Now, at this point, this problem is pretty much the same as the 21.4 we just did. The index is 2. So I'm going to raise both sides of the equation by the number 2 because I have to do that. Always the index. On the left side, this 2 right here cancels with that 2. I am going to be left with the radicand. And on the right, I have 3 squared. At this point, I solve the remaining equation, which again turns out to be a linear equation. So plus 6 on both sides. Right, they cancel. 3x, 15. And again, divide both sides by 3. The 3's cancel. I get 5. This is my solution, but it needs to be checked to see if it's okay. So let's check. All right, I'm going to replace x with the number I have. So 3 times 5 minus 6 plus 2 equals 5. Now, this is in the original equation, okay? So 3 times 5, 15. 15 minus 6 is 9. Right? Plus 2 equals 5. Well, this is 3. Yep, that works. So this is my answer. So that's okay. Okay, so these two examples were pretty straightforward. The first one, we didn't need to do the first step because it was already isolated. In this case, we did. We cannot begin the problem with this positive 2 here. Okay, so let's see the next batch of problems. And I think in this case, I am going to do 21.10 first. It's a little bit different, but very, very easy. The radical is isolated. Maybe I should write the steps again. 1, 2, 3, and 4. Isolate. Isolate the radical. Raise to the index. Solve the remaining equation and check. These are the 4 steps. In this case, again, the radical is already isolated. And I need to now raise both sides to the index. But in this case, the index is 3. Which is okay, not a big deal. So 3 goes right here and goes right here. On the left side, this cancels the index with the 3. I'm left with the radicand 5x plus 14. On the right side, I have to do 4 cube, which is 4 times 4 times 4, which is 64. And now I'm going to solve. I'm on step 3, solve the remaining equation, which again looks like a linear equation. So minus 14 on both sides. All right, they cancel. I have 5x. 64 minus 14, which is 50. Divide both sides by 5. These two 5s cancel, and I get that. So this is my supposed solution. We already know now step 4, we have to check. You check in the original equation as before. All right, so here we go. This is a cubic. So 5 times 10 plus 14, is that equal to 4? So this is 50 plus 14, 64. Is the cubic of 64 4? Yes, it is, because 64 is just 4 to the 3rd power. And again, this cancels with that, and I have 4 equals 4. So that works. So my answer is 10. This is correct. All right. So it doesn't really matter what the index here is. We will raise both sides of the equation to the index, as you saw before. All right. 21.7. I have a situation again that the radical is not isolated. So I have to get rid of this minus 1. So I have to do minus 1 on both sides. They cancel here. I have x minus 1. Isolated now. The index is 2. By default, I raise both sides of the equation to the square, to the index. On the left side, this cancels with that. I am left with 5x plus 19. On the right side, I have to do x minus 1 times x minus 1. I have to FOIL. We've done this before, right? So x times x times negative 1, negative 1 times x, negative 1 times negative 1. Combine like terms. And that goes over here. Okay, so this is what we have. Now, this is a quadratic, which we have to solve, and we know on the quadratic, we have to set the quadratic equals to 0. So I'm going to change it. I'm going to write this thing first and this thing after, because I want the square to be on my left side. So x squared minus 2x plus 1 equals 5x plus 19. Now I can do that because if 5x plus 19 is equal to this, then this is equal 5x plus 19. Now I am going to make the quadratic equals to 0, so I have to subtract 5x on both sides, and I have to subtract 19 from both sides. Okay, now this is going to be 0, which is what I want. X squared minus 7x minus 18 equals 0. I need to find, if you remember, product and sum. Product is 1 times negative 18. Sum is negative 7. So I can see all of the possibilities here, but I think maybe you already have some experience and you suspect that this is going to be minus 9 and positive 2, right? So the 1 and 18 doesn't work, the 3 and the 6 doesn't work, so minus 9 and positive 2, right? The product is negative 18, the sum is negative 7. All right, so now I can factor this by grouping, okay? And it's going to turn out to be this. Okay, I skipped it a little bit because I'm running out of space. And now you apply the zero product rule, which means x minus 9, 0, or x plus 2 equals 0. So add 9 to both sides, I get x equals 9. Subtract minus 2 from both sides, and I get this. So I have two possible solutions, which we need to verify. I'm going to erase this a little bit because, again, I'm running out of space. All right, so let's check. So let's check the first number first in the original, okay? You check it in the original. So here is the original equation. So let's check 9 first. So 5 times 9 plus 19. Notice that the 1 is on the outside of the radical, and 9. Okay. So 5 times 9, 45, plus 19, 64. All right, so this is 9. So radical 64 is 8 plus 1, 9. That works. So that means that x equals 9 is an answer. Check the negative 2. All right, so 5 times negative 2 plus 19 plus 1 equals negative 2. All right, so this is negative 10 plus 19 radical 9 plus 1 equals negative 2. Well, radical 9 is 3 plus 1 is 4, which is not equals to negative 2. So this is not a solution. So on the exam, you make sure that you either cross this or you make a very clear solution, right? Only this value. So there's absolutely no misunderstanding that negative 2 is not an answer. Okay. All right, so that was good. So let's see if I have another example for us to do. Yes, we do. We do. This is the last type. So we saw kind of maybe 2 or 3 types. one where, you have to isolate the radical, cases where we had the cubic index or the square index, as you saw here previously. And now we're going to see the last type that usually comes up, which is this case right here. This is possibly, even though it's the one that we covered the last, this is the easiest case. Okay, so in this case, look at the equation. We have a radical on the left and a radical on the right. So how do we isolate them? So this is easy because in this case, both radicals are already isolated, each on its own side. So we don't have to do anything anymore. We check the index. Both indices are 2. So we raise both sides of the equation to the power of 2. On the left, they cancel. On the right, they cancel. So I'm left with the radicand on the left. I'm left with the radicand on the right. And now we solve the remaining equation, which is a linear equation. So minus 5x on both sides. Is 2x plus 1 equals negative 15. Minus 1 on both sides. Divide everything by negative 2. We got 8. We got to check the solution in the original again, right? Always checking the original. So I have 3 times 8 plus 1. 5 times 8 minus 15. So this is 24 plus 1, 25. This is 40 minus 15, also 25. Yes, radical 25 is equal to radical 25, which means that this is our solution and we're done. Okay? So this case is very simple. When you have radicals on both sides, if they're already written this way, they are already each isolated and you're done. Well, Professor, but what if one is radical 2 and the other is radical 3? Yes, that is a possibility, but for your exam and your final, we are never going to give you a situation like this. So you don't have to worry. This is a more advanced type of problem. The only thing that you are going to be given is something like this, where both are either indices 2 or maybe both are indices 3. Okay, and you're going to solve it the exact same way as I did over here. All right, so this is how we solve these radical equations on section 21.